Bismillahirrahmanirrahim. Hello everyone, I hope you are all fine. I welcome you all in class of O-level mathematics. I am Professor Azmat Ali. Our discussion is continue on linear inequalities in two variables. In the last lectures, we have discussed some problems related to linear inequalities in two variables. In that lecture, I have discussed how to shade a given linear inequality. In our previous lecture, we shaded the region that satisfies the given inequalities. The shaded region represented the solution set or solution region. In today's lecture, I am going to discuss a problem that is actually worked example 1. That is available in the book New Syllabus Mathematics by Dr. Yeap Ban Har. But the approach of this book is slightly different. In today's lecture, the required region will be unshaded. While in my previous lecture, I focus on that our shaded region was, our required region was shaded. So in today's lecture, we are discussing a problem when our region is unshaded. So, however, in today's lecture, the required region will be unshaded instead of shaded. This means we will shade the region that does not satisfy the inequality, and the remaining unshaded part will be our solution set. So, let us start the example properly. The problem is that show unshaded the region satisfied by the following inequalities. First inequality is x greater than or equal to 0. Second is y greater than or equal to 1. Third is x plus y less than or equal to 5. And the fourth one is y less than x plus 3. When our required region is unshaded, we will use the following strategy. I will firstly find an inequality that is opposite to this. The inequality opposite to x greater than or equal to 0 is actually x less than 0. Similarly, the inequality opposite to y greater than or equal to 1 is actually y less than 1. The inequality opposite to x plus y less than or equal to 5 is actually x plus y greater than 5. That is simply obtained by taking opposite sign to less than or equal, that is greater than. Similarly, the inequality opposite to y less than x plus 3 is actually y greater than or equal to x plus 3. So firstly, we will find the inequalities opposite to the given inequality. Next we find boundary lines or associated equations. Boundary lines that is also called here associated equations. These boundary lines or associated equations can help us to draw the graph of given inequalities. The associated or boundary line of this x less than 0 is simply equation x equal to 0. That is just obtained by replacing less than sign with equal sign. Similarly, the boundary line of this y less than 1 is y equal to 1. The boundary line of this inequality is x plus y equal to 5, and last one, its boundary line is y equal to x plus 3. Now, next we draw a graph of these four inequalities, something as we draw y-axis. Suppose this is our y-axis and this is our x-axis. This is our x-axis. This is origin and this is y-axis. So firstly we draw the graph of x less than 0. Its boundary line is x equal to 0. Do you know x is equal to 0 is actually y-axis. This is y-axis. And x less than 0 shows the region to the left of y-axis. X less than 0 means region left of y-axis. Region left of y-axis. So where is region left of the y-axis? This all region. This all region is to the left of y-axis. So this shows the shaded region. The shaded region shows x less than 0. Next we draw the graph of y less than 1. Y less than 1. What is its boundary line? Its boundary line is y is equal to 1. Where we can locate y is equal to 1. Y is equal to 1 is actually the point on the y-axis. Suppose this is y is equal to 1. This is y is equal to 1 here. Next we draw boundary line of y is equal to 1. This is the straight line. This is actually horizontal line that shows the graph of y is equal to 1. This straight line shows the graph of y is equal to 1. But we need to find the graph of y less than 1. Y less than 1 means the region below this line. When we have less than sign, it shows graph will be below this line. So graph is below this line. So this is this shaded region shows graph of y less than 1. Further, it is always remembered that because of these two given inequalities have equal sign, so their boundary line will always be a solid line. Mean to say, if in our question we have only y greater than 1, then we will draw this line y is equal to 1 as a dotted line. So the region below this line shows graph of y is equal to y less than 1. This is the graph of y less than 1. Y less than 1. Next inequality is actually the inequality in two variables, that is x plus y greater than 5. So its opposite inequality is x plus y greater than 5 and its boundary line is x plus y is equal to 5. In my previous lectures, I have completely discussed how can we draw the graph of two variable inequalities. Here boundary line is x plus y is equal to 5. We draw on both sides, we divide on both sides by 5. We have x over 5 plus y over 5 is equal to 1. This shows two intercept form of line. What does this show? This is two intercept form of line. form of line. Here the number in the denominator of x, that is 5, this shows x-intercept, and similarly the number in the denominator of y is also 5, that shows y-intercept is also 5. It means the line cut x-axis at x is equal to 5 and y-axis also at 5. So firstly we plot x and y-intercept of the line. X and y-intercept of the line. Suppose this is x is equal to 1, 2, 3, 4, 5. This is x is equal to 5. Similarly, suppose this is y is equal to 1, 2, 3, 4, 5. This is y is equal to 5 here. Now we join these two intercept with each other like this. So extend this line. So this green line actually shows the graph of x plus y is equal to 5. Next, but we need to draw the graph of boundary line x plus y, need to draw the graph of inequality x plus y greater than 5. Greater than 5 means graph will be above this line. So we shade the graph above this line. This shaded region shows the graph of inequality x plus y greater than 5. This shaded region is x plus y greater than 5. Lastly, we need to draw the graph of the inequality y greater than or equal to x plus 3. Its boundary line is y is equal to x plus 3. So we convert this boundary line into two intercept form. Y is equal to x plus 3 here. We can write it as minus x plus y is equal to 3, dividing on both sides by 3 to make right side equal to 1, because you know x over a plus y over b is equal to 1 is the standard form, is the standard two intercept form of a line. So dividing on both sides by 3, we have x over minus 3, y over 3 is equal to 1. This shows that our x-intercept is minus 3 and y-intercept is 3. So we plot these two intercept. Where is x is equal to minus 3? X is equal to minus 3 will be here. Suppose this is x is equal to minus 1, this is x is equal to minus 2, and this is x is equal to minus 3. Suppose this is x is equal to minus 3 here. Where is y is equal to 3 here? Y is equal to 3, this is y is equal to 1, y is equal to 2, y is equal to 3. This is y is equal to 3. Now joining these two intercept, we have, I should change the color of the marker. Okay. So by joining these two intercept and by extending the line, this boundary line is actually shows the graph of y is equal to x plus 3. Further, you can notice that here our given inequality, actual inequality, have only less than sign, so its boundary line will be dotted line. So its boundary line should be a dotted line like this. This should be a dotted line joining these two intercepts. So Uh, Now the remaining region, that is here unshaded, is this. This is our required region that satisfy the given region. This is unshaded solution region. This is unshaded solution region that satisfy always all of the given inequality. You can check whether the unshaded solution region is a correct region or not by taking any point from this region. Suppose here this region, in this region x is equal to 1 and also y is equal to 2 here. So one of the point that lies in this region is x is equal to 1 and y is equal to 2. If you put if you put this point x is equal to 1 and y is equal to 2 in all of these inequality, you can notice that this point will satisfy this all of the inequality. For example, if you put this point x is equal to 1, y is equal to 2 in the last inequality, we have 2 less than 1 plus 3. This is 2 less than 4. And one of the important point that I have forgotten here, what is the shaded region for this inequality y greater than x plus 3. So y greater than x plus 3 is actually this region shows the graph of this shaded region shows the graph of y greater than or equal to x plus 3. If you have any doubt in shading of the region of inequality, you can take a test point here. What do you mean by the test point? Test point is a point that can help you to determine the direction in which we have shade. For example, here our inequality is y greater than or equal to x plus 3. Y greater than or equal to x plus 3. For our convenience, we take 0, 0 origin as a test point. If we put y is equal to 0 here and x is equal to 0 here, 0 plus 3. 0 is greater than or equal to 3. Whether this inequality is true? No, this is false. This shows that when this inequality becomes false, this shows that the graph of this inequality will not towards the origin. So the graph of y greater than or equal to x plus 3 is away from the origin. Away from the origin. So this is a complete method to shade the or to find the unshaded region for the given system of linear inequality. I hope today video is helpful for you. If you find my lecture helpful for you, kindly like, share and comments. So see you in the next lecture. Take care. Allah Hafiz.